While the James Webb Space Telescope has found an Earth-sized planet, but with no atmosphere.
Meaning that pretty much if there is anything there, it doesn't exist and really isn't hospitable. The second and third planets, and that's what really we're excited by when James Webb starts to look at those, because those are the ones that are in similar positions to, say, Venus and Earth, which really should be, and hopefully are, having atmospheres and habitable.
On a distant world, a year races by in just 4 days. Sunrises and sunsets flash across the sky almost before they can be savored, under the dim red glow of a small, cool star. This is no work of science fiction. It's TRAPPIST-1d, one of 7 Earth-sized planets orbiting the faint star TRAPPIST-1, 40 light-years from Earth, each locked in a precise and mesmerizing cosmic rhythm. Today, astronomers are pushing the boundaries of discovery, peering deeper into these distant realms than ever before, using the unmatched power of NASA's James Webb Space Telescope. Their mission: to unveil the hidden secrets of TRAPPIST-1d and to answer one of humanity's oldest questions: could another Earth exist out there among the stars? Our story begins with TRAPPIST-1, a red dwarf star so faint that it can't be seen with the naked eye from Earth. Despite its subtle glow, this small star is home to one of the most extraordinary planetary systems ever discovered. 7 rocky worlds, all roughly the size of Earth, orbit in tight formation, with the closest planet circling the star in just a matter of days. In 2017, data from NASA's Spitzer Space Telescope revealed this planetary family, sending ripples of excitement through the scientific community. Here, at last, was a system packed with Earth-sized planets, 7 of them, each presenting the tantalizing possibility of water, atmospheres, and maybe, just maybe, life. Among these worlds, TRAPPIST-1d stands out. Positioned as the 3rd planet from its star, it sits right on the edge of the so-called habitable zone, a region where temperatures could, in theory, allow liquid water to pool on the surface. Unlike our solar system, where the habitable zone lies far from the sun, the cooler nature of red dwarf stars means their temperate zones are much closer in. TRAPPIST-1d orbits at just 2% of the distance between Earth and the sun. Its year, a complete orbit around the star, lasts only 4 Earth days. But what is this distant world really like? Is it a lush, blue planet, wrapped in clouds and seas? Or is it barren, rocky, and airless? To find out, scientists turn to the James Webb Space Telescope, or Webb for short, the most powerful space observatory ever built. Webb's sophisticated instruments are designed to study planets in detail, even those so far away that they appear as mere points of light. Webb's near-infrared spectrograph, or NIR spec, was aimed at TRAPPIST-1d to search for signs of an atmosphere. By watching as the planet passed in front of its star, astronomers could look for subtle changes in starlight, signals that certain molecules were absorbing specific colors of light as they filtered through the planet's air. Molecules like water vapor, methane, and carbon dioxide, all found in abundance on Earth, would reveal themselves as telltale dips in the spectrum. The results, however, were surprising. Webb's sensitive detectors found no obvious signs of these atmospheric molecules on TRAPPIST-1d. Unlike Earth, this planet did not reveal the chemical fingerprints of a thick, life-friendly atmosphere. But what does this absence mean? Is TRAPPIST-1d truly a barren rock, stripped of any air by the harsh conditions near its star? Or could it still harbor a thin or hidden atmosphere, one that even Webb's powerful vision could not yet detect? Scientists suggest several intriguing possibilities. TRAPPIST-1d might possess an extremely thin atmosphere, like the wispy carbon dioxide envelope that clings to Mars. Such an atmosphere would be difficult to spot, even with the latest technology. Alternatively, TRAPPIST-1d could be shrouded in thick, high-altitude clouds, much like Venus in our own solar system. These clouds could be so dense that they block the planet's atmospheric signatures from view, masking their presence from Webb's instruments. Or perhaps this world is a true airless rock, its atmosphere long since swept away by the relentless energy of its star. This brings us to a cosmic challenge faced by all planets orbiting red dwarf stars. Unlike our gentle sun, red dwarfs like TRAPPIST-1 are known for violent outbursts, flares of high-energy radiation that can scorch nearby planets. For worlds like TRAPPIST-1d, bathed in this stormy environment, holding onto an atmosphere is a constant struggle. The closer a planet orbits to its star, the more exposed it is to these powerful stellar winds, which can strip away gases and leave a planet bare. Despite these harsh conditions, the search for atmospheres in the TRAPPIST-1 system is far from over. Red dwarfs are the most common stars in our galaxy, outnumbering sun-like stars by the billions. If planets can retain atmospheres here, even for a short time, it suggests that habitable worlds could be much more common than once thought. Webb's exploration of TRAPPIST-1d marks a turning point. For the first time, astronomers are able to examine Earth-sized planets around other stars in detail, probing their skies and searching for the dividing line between planets that can hold on to an atmosphere and those that cannot. Each observation, each spectrum, adds a new piece to the cosmic puzzle of habitability. While TRAPPIST-1d may not be an Earth twin, its story is far from a disappointment. Instead, it's a crucial clue in the grand quest to understand what makes a planet truly special. The absence of a thick, life-sustaining atmosphere on this world challenges our assumptions and sharpens our focus as we look to the other planets in the TRAPPIST-1 system, planets that orbit farther from the star, where flares are weaker and the possibility of retaining an atmosphere is greater. Webb's ongoing mission is just beginning to reveal the secrets of these distant worlds. Each observation brings us closer to answering profound questions about the universe. How common are planets like Earth? What conditions are truly necessary for life to take hold? And ultimately, are we alone? As scientists continue to explore the TRAPPIST-1 system, the discoveries made here will lay the foundation for future missions that could one day find new Earths and perhaps even evidence of life orbiting stars across our galaxy. With the James Webb Space Telescope's keen infrared eyes trained on TRAPPIST-1d, astronomers have reached a pivotal milestone in the quest to understand the diversity of planets beyond our solar system. Webb's observations reveal that TRAPPIST-1d, though similar in size and rocky composition to Earth, does not exhibit the atmospheric signatures we associate with a potentially habitable world. No clear evidence of water vapor, methane, or carbon dioxide has emerged from the data, at least not in quantities large enough to be detected with current technology. Yet this outcome is far from a setback. In science, every answer, whether expected or not, reshapes our understanding and brings us closer to the truth. TRAPPIST-1. D's apparent lack of a thick, Earth-like atmosphere may tell us as much about the formidable environment around red dwarf stars as it does about the planet itself. Red dwarfs, like TRAPPIST-1, are notorious for their frequent and intense stellar flares, releasing torrents of high-energy radiation. These outbursts can strip away planetary atmospheres over time, especially for planets orbiting close in, like TRAPPIST-1d, which completes a full year in just 4 Earth days at a mere 2% of Earth's distance from our Sun. But this is only the beginning of Webb's investigation. While the third planet, TRAPPIST-1d, may not join the shortlist of potentially habitable worlds, attention now turns to its siblings, planets E, F, G, and H, circling further from their tempestuous star. Here, the prospects grow more intriguing. These outer worlds rest at greater distances, possibly shielded from the majority of their star's harshest flares. This increased separation could allow them to retain atmospheres, perhaps even with key ingredients like water vapor. Detecting atmospheres around these colder, darker exoplanets is a formidable challenge. Webb's sensitive instruments must sift through faint signals, teasing out the fingerprints of molecules from the glare of their parent star. But if these planets hold on to even the thinnest veils of air, Webb may be able to reveal their secrets. Such findings would not only inform the search for life, but also help astronomers map out the conditions that allow atmospheres to persist in the universe's most common planetary environments. This focus on red dwarf systems is no accident. Red dwarfs make up about 75% of all stars in our galaxy, and many are host to small, rocky planets. If astronomers discover that atmospheres, and by extension, potentially habitable environments, can survive the punishing radiation from these stars, it would vastly expand the number of places where life might take root. Conversely, if atmospheres are rare or fragile in such settings, that too provides a crucial piece of the cosmic puzzle, helping refine the search for true Earth analogs. Webb's mission is not only about collecting data, it's about testing theories, challenging assumptions, and laying the groundwork for future explorations. Each atmospheric measurement, each planetary spectrum, adds to a growing library of knowledge that will inform the design and focus of upcoming observatories. NASA's planned Habitable Worlds Observatory, for example, will be able to build on Webb's legacy, targeting promising exoplanets with even more precision, and perhaps one day detecting biosignatures, chemical clues that hint at life's presence. Meanwhile, Webb continues to peer into the darkness, revealing the unexpected complexity of planetary systems like TRAPPIST-1. Its discoveries extend beyond exoplanet atmospheres, delving into the origins of stars and galaxies, the birthplaces of planets, and the fundamental processes that shaped our cosmos. Every observation carries the potential for a paradigm shift, a new chapter in humanity's understanding of our place in the universe. As we look up and contemplate these distant worlds, the quest endures to find another Earth, to glimpse a faint blue dot in another star's sky, and perhaps one day to answer the age-old question, are we alone? The journey is only beginning, and with each technological leap, we move ever closer to unraveling the mysteries of the cosmos. If you found this exploration of the TRAPPIST-1 system as fascinating as we do, make sure to like this video and subscribe for more content like this. Join us on the next adventure as we continue to follow the trail of discovery through the stars.